Hello everyone, today I will be making a short explainer video on this thing that I've built in Logic Bots, which is essentially a video game within a video game. I've made a short showcase video on it earlier. Now, this is basically a game of Highway, which is a kind of classic arcade game. It's not quite up there with Space Invaders or Pong, but it's one of those really basic games you can make for exercise because they're really simple. The idea being that these lights, they're supposed to be cars or whatever. There are hundreds of different thematics on this. There are different versions, but in this case they're just LED lights. Go down there in some sort of pattern and you kind of have to dodge them. And if you collide with one for too long, that is, in this case, you've basically collided already. The lines don't go to the lowest line. The lowest line only indicates where you are. You collide if the highest and the lowest, not the highest, the second lowest and the lowest line have one LED matching. If this happens from too long, because the randomizer isn't very sophisticated, so it might spit out patterns that are impossible to dodge, so I wanted to make it that if you're fast enough you can kind of jump over one LED. So if you collide with one for too long, then the game is basically over, and this number monitor basically just outputs how long you've survived, and this one is just if it's going right now. I can show you a little demonstration here. Now the randomizer sometimes throws weird patterns, especially when recording, because the randomizer is based on the game's lag, because there is no real randomizer in Logic Bots, so I had to build one, and that is basically a fake randomizer that is based on adding up the lag of a game's simulation and coming to a result that is usually not very predictable. Now, for the circuitry, this is a whole bunch of circuitry. Now, we can kind of split it up into blocks. This first kind of block here is basically just a counter that essentially counts your position from 0 to 4 and basically indicates where you are, and counts up and down with this RC receiver, which I use as an input. I chose these buttons because the common direction buttons are already used by Logic Bots itself. So if I use like the arrow keys, then this keeps happening. And so I had to use these kind of center keyboard buttons. The counter is limited to up and below. That is, if you try to go below 0, it goes back up, and if you try to go above 4, it goes back down. And then there is a basic counter if the game is running right now or not, and a basic start-stop mechanism. And here is where it gets more interesting. Here we have the randomizer, which is essentially a delay of 1 millisecond feedbacked into itself with a NOT gate, which causes it to flicker on and off all the time. Now 1 millisecond is very short, so the lag of the simulation of Logic Bots adds a significant amount of time to this happening. And usually this looks like it flickers randomly and is essentially just on half the time, off half the time. Now it behaves a little weirdly because of recording it, and recording software kind of interacts weirdly with video game frame rate and simulation lag. But this thing is counted and it basically works as a clock that makes a counter go up, and if it reaches 100 it resets itself, and thus this number runs up to 100 and starts over again really quickly, and over several seconds the added up amount of lag is essentially unpredictable. Since you're in a cycle of 3, you don't know where in the current cycle you are, and the number is then divided by 3 and rounded, and then the rounded number is subtracted from the original divided by 3 number, so we get minus 1/3, 0, or 1/3, and we check if that is bigger than 0.1, so we essentially get a randomizer that has a 1 in 3 chance of being on at any time. And to split that into 5 different random outputs, we just use different delays, because that randomizer just keeps changing all the time. Basic delay allows us to get 5 different values. Then here are some basic flip-flops that I built. There would have been a simpler solution using basic counters, but I thought this was more interesting. Now a flip-flop is basically 2 NOT gates wired feedback back into each other. So either one is on or the other one is on, and it keeps itself in that state and can thus save 1 bit of information. The rest is basically a mechanism to write into that by having a little break in that circuit and saying that one is on. If the other one is on, or you get an input from somewhere else. So it's basically just these 2 NOT gates. The rest is just the mechanism to write into it and read from it. And then we have 5 times, 1 for each column. And whenever this timer, which is only running if the game is currently running, whenever this timer counts up to 1.05 seconds and then resets itself, so every 1.05 seconds it gives a short signal, and if that signal is on, then the state of the one of the delayed randomizers is written into these flip-flops, and these flip-flops control the top line of LEDs. Then there's just a huge cluster of 1 second delays and LED pass-throughs, so it moves down to the lowest line of LEDs at 1 line per second. And that lowest line of LEDs is then compared to your line, the actual lowest line of LEDs. And if 2 matching LEDs are on, then this timer counts up. And if it's not the case, then the timer is reset. But if the timer keeps going for 0.2 seconds, then the game is stopped. And that brings us basically back to the start-stop mechanism we built back here. So I hope that explanation was kind of interesting. I've already made a short showcase video, but I can show it in action for a few more seconds. And hope the randomizer doesn't bug around due to recording. Now, as you can see, sometimes the randomizer just spits out patterns that are impossible to dodge, because it's just not sophisticated enough to be... Of course, you could make a really sophisticated randomizer that only turns on certain LEDs if others are turned off, so it can't put out a pattern that is impossible to dodge, but I didn't go that far, and the randomizer, since it's a fake randomizer based on game lag and recording always somewhat influences the lag, the randomizer does sometimes output weird patterns, but generally it's kind of playable. And as you can see, if you collide for a short enough time, you can kind of still dodge it because of that 0.2 second timer. Now I hope this video was somewhat interesting, and thanks for watching.